So the next question is comparison between open loop and closed loop control system. So here I have made some of the points for open loop and closed loop control system. This is the difference between them. That is, open loop control system has less accuracy. Okay, closed loop control system has more accuracy. Open loop control system is sensitive to noise, disturbances and external changes in environment. Closed loop control system is less sensitive to noise, disturbances and external changes in environment. Open loop control system, from the point of view of stability, it is easier to build, and closed loop it is more complex and expensive. Open loop it is less in power and cost. Closed loop it is higher in cost. Open loop it is convenient when output is hard to measure or not. Then robust sensors are used in case of closed loop control system. Output quality is not guaranteed in place of open loop control system. Output quality is maintained and it is guaranteed in place of closed loop. Recalibration of device from time to time is necessary. Recalibration is not necessary. Feedback element is absent in case of open loop, and feedback element is present in case of closed loop control system. The error detection is absent in case of open loop, and error detection is present in case of closed loop control system. And transient and steady state error cannot be controlled conveniently in place of closed loop control, open loop control system, and transient and steady state error can be controlled conveniently in place of closed loop control system. Okay, so these are the few of the main differences here between open loop and closed loop control system. So you can note it down. Okay, this is very important. Also, I have provided you some of the advantages of closed loop control system over the open loop control system if you want. These are the 4 important points here. You can pause the video and you can note it down as well. Okay, so hello everyone. So from this session onwards, we are going to discuss with the control system model question paper 2 solutions. Okay, model question paper 1 solutions is already available in our channel, so those who have not seen it, so you can refer it. Okay, since the exams are coming near, so we had taken a lot of time to do this because the problems are a bit lengthy and very tough to do. So that's why we have taken the time and provided you the solutions for model paper 1 and 2. Okay, so that's why please stay tuned to our channel and watch these solutions. Okay, make a note of this, note it down. While I'm explaining it, you can note it down in your hand only, so it would be beneficial for you if you make a hand notes. Okay, so this was the first question in the model paper provided. This was the second question in the model paper. First question is related to comparison of open loop and closed loop, that you already might have seen it. So this is the second question, that is, draw the mechanical network for the system shown and write the equations of performance and draw its analogous circuit based on FV analogy. So this is the translational system, they have given it here. First you need to analyze the translational system here. See, since we have 3 masses, so it's obviously that how many number of masses are there. Most of the times that many number of displacements would be there, that is 3 displacements. Okay, so that's why what we should be doing, 3 nodes here, x1 of t, x2 of t, x3 of t, separately draw all the 3 nodes. Okay, then after that, from x1 of t, what and all are the components present from the, we can see that due to this displacement cost, what and all are the components. One is the force here, so from this node draw the force f of t. Then we can see that this mass is due to this displacement, so m1. Then from the same node, this friction is not between m1 and m2, it is placed between one on dispenser. It is connected to one dispenser, it is not directly connected to m2. So that's why this b1 will not lie between these 2 displacements x1 and x2, it is only in between for x1. Similarly k1 also it is for x1. Then we can see that this k3 is attached between m1 and m2. Okay, so that's why this k3 lies between x1 and x2. Similarly for x2 of t, m2, b2 and k2. Okay, b2 and k2 are connected to one dispenser, and k4 is between m2 and m3. So that's why the k4 would be lying between the displacements x2 and x3, then m3 for the displacement x3. So like this we should be drawing first the equivalent mechanical network, then the equilibrium equations at node 1, 2, 3. Okay, at node 1 this is the equilibrium equation, what are the components present through node 1, it is m1, b1, k1 and k3. So m1 into d square, the displacement x1 of t, then b1 into d x1 of t by dt, k1, then k3. K3 lies between these 2 nodes x1 and x2, so that's why it is x1 of t minus x2 of t. So name it as equation 1. Then similarly at node 2, what and all are the components present at node 2, that you should be noting down here, that is m2. You can see here node 2, m2 K2, B2 as well as K4. Okay, so that's why M2 d square x2 of t, the displacement is x2 of t, plus B2 into dx2 of t by dt, K2 into x2 of t plus K3 into x2 of t minus x1 of t, since K3 lies between x1 and x2, but we are taking with respect to node displacement x2, right? So that's why first x2 would be coming. Then at node 3, similarly, what are all the components present? M3 and K4. So that's why M3 d square x3 of t by dt square plus K4 x3 of t minus x2 of t. So name this equation as equation 3. And also they already told us to do the FV analogy part. So that's why FV analogy for equation 1, we know that force is replaced by voltage V of t. Then M is replaced by L, so that's why L, and in place of M1 you would be giving L1. Then B is replaced by R and K is replaced by 1 by C. Also X is the displacement is replaced by the charge Q1. Okay, so all the substitution I've done it. Then we know that we can split this as d by dt into dq1 by dt. So that's why dq by dt, we know that I is equal to dq by dt. So that's why we have dq1, so that's why it is I1. So here also in place of dq1 by dt we are getting I1. So we have q1, so that's why we know that since I is equal to dq by dt, so that's why what would be our value of q? If we take this d by dt to other side, it would be integration of I. So that's why in place of q1 I have written it as integration of I1. Similarly 1 by c3 into integration of I1 minus integration of I2. Then take the Laplace transform for this equation. So that's why v of t would be equal to v of s now into L1 into s. So d by dt is replaced by s and the integration sign is replaced by 1 by s. So that's why I have written here 1 by c1 into s, and all the I1 terms would be replaced by I1 of s, and all the I2 terms would be replaced by I2 of s. So this equation, note it as equation 4. Similarly for the second equilibrium equation, for equation 2, do the substitution. In place of M it is L, B it is R, and K it is 1 by C. All the substitution I have done it. Okay, and in place of displacement I have written the charge, whichever the charge present. Then I have taken the substitution here, L2 di2 by dt plus R2 I2 plus 1 by C2 integration of I2 plus 1 by C3 integration of I2 minus integration of I1. Okay, then again take the Laplace transform. Okay, take the Laplace transform. This is the equation we get. Note it down as equation 5. And similarly for third equilibrium equation, apply the FV analogy rule. Okay, again the same thing. M is replaced by L, and here we have K, right? So K4 is replaced by 1 by C4, and all the substitutions have done it. Take the Laplace transform and write the equation in S domain. Okay, and name it as equation 6. So now using equation 4, 5 and 6, this is the equivalent electric network we get in place of FV analogy. We can see that the C3 component lies between the loops I1 and I2. Okay, we know that in FV analogy, if in order to draw the FV analogous circuit, we should be using mesh loop currents, along with all the components should be connected in series in all the single loops. Okay, in case of FI analogy, we should be using the analysis of node analysis, and all the components should be connected in parallel. Okay, hope you might be knowing this. So in this way, here we can see that C3 lies between I1 and I2 loops, and C4 lies between I2 and I3 loops, and L1 C1 R1 and L2 C2 R2 are in series for respectively for the loops I1 and I2, and for I3 we have only one single component, L3. Okay, so compare all these 4, 5, 6 equations and draw the equivalent electric network. Okay, so that's all for this question. So hope you understood this question very thoroughly. So please note this question down. This is very important. Okay, purpose. So now this is the main definition that you need to know about the control system. This is basically the subject, so you need to know this, but this is a very important point you need to highlight. That is an interconnection of components forming a system configuration that will provide a desired response. Okay, so this is called control system over here. So the next thing is in control system we have again two types of control system basically. That is open loop control system, which is another important concept, and another one is closed loop control system, which I will be discussing in the upcoming sessions. First, let's see what is this open loop control system. So in open loop control system, this is the basic block diagram of this open loop control system. That is input. After that we are going to having a controller, actuating signal, a planned processor, and an output. So these systems in which the output has no effect on control action are called open loop control system. Whereas in a closed loop control system, the output is neither measured nor fed back for comparison with the input. Okay, So here we might be having the difference between open loop and closed loop. So this is very very important here, you need to know it. Okay, that is the differences between open loop and closed loop control system. So let's get to this one by one. So please listen carefully students, because this is very very important here, differences of open loop and closed loop. Okay, yeah, so the first point is less accuracy for open loop, and closed loop control system has more accuracy. Okay, since open loop control system, the in which the output has no effect on control action, that's why it has less accuracy, because uh, the output is not directly dependent upon input. That's why in closed loop control system the output would be dependent upon input, so that it would be having the more accuracy. Okay, so the next point is sensitive to noise disturbances and external changes, and this is less sensitive. So the third point is from the point of view of stability, it is easier to build, and for the point of view of stability, it is more complex and expensive. Here it is less in power and cost, and closed loop control systems are higher in cost and power, as they use more components, because in closed loop control system basically we are using more of the most of the mechanical components. That's why this is higher in cost, and convenient when output is hard to measure, that's for the open loop, and robust sensors are required to measure the output, because we need some of the sensors to measure the output for this closed loop control system here. So the output quality is not guaranteed, and here the output quality is guaranteed in case of closed loop, and a recalibration of device from time to time is necessary, and recalibration is not necessary in case of closed loop here. And the feedback element is present, this is a very important point. Feedback element is present in case of closed loop, and it is absent in case of open loop, and we can find the error we cannot find the error very easily in case of open loop control system. So that's why error detection is absent, and error detection is present in case of the closed loop control systems. Okay, so these are basically the points we need to note down. These are how many points are there? 9 points. Okay, so please print it in your mind, because this is very very important here, difference. So now we'll get to few of the exciting concepts here related to the uh, control system. Before that, if you want, you can note down these advantages. This is basically the theory part, advantages of closed loop control system over open loop. This is also, and if you want, you can note this down. Just see, there are 4 of the advantages about the, I've discussed about the differences, right? The less sensitive, more sensitive, and main advantage of this closed loop system is to provide the necessary output, whereas open system, the output is not dependent upon the input. That's why the formation of output is very hard in case of open loop. Okay, so now again we have one more concept. It's a very important concept for this subject. Okay, that is transfer function. Okay, see this transfer function, please make a note of this. So what does this transfer function means? It is the mathematical representation of the relationship between the input and output of a system. It is commonly used to control theory and signal processing to analyze and design systems. For example, if you take a desired circuit, for example, any electrical circuit which has a resistor, capacitor, and a voltage source, for that the desired output is measured in terms of a relationship between those resistors and all the voltage sources. For example, if we have a voltage source series with the resistance, we can calculate the current easily. We know that the formula for current is I is equal to V by R, right? Yeah. In similarly, in case if you want to calculate voltage, we know that if you cross multiply this, the formula is V is equal to I into R. That is the Ohm's law. That is called as transfer function in case of this control system. Okay, because the main thing of control system that you need to know is in this control system topic, the mechanical system would be given to you guys. You need to convert it to an equivalent electrical system and then analyze that circuit. This is basically the concept of control system. Basically, the subject definition for this course only, you can say that a mechanical system is converted into an equivalent electrical system, and that electrical system is analyzed by using some of the concepts that we are discussing right now. Okay, So now let's get to one more concept that is very important. It might be blur, but I'll read it out to you guys. Okay, yeah. So the next concept here is damping, another very important concept. Okay. So what does this damping mean? The term damping in physics is typically refers to an effect that causes the reduction in the rate at which some process can take place. That is, basically we can say that damping is nothing but it is equivalent to friction. Okay. So this friction typically refers to a dissipative force acting on a system or between two objects. That is friction. If we rub our hands, right, that's basically a friction. Okay. So if you are feeling very cold, most of the people what they do, they rub their hands and make their hands warm and place it on a face. So that rubbing their hands is basically the friction between two objects, like that is opposite forces. We can say that opposite forces are attracting each other, so that friction happens. Okay. So in order to represent this in a control system, we use this formula, that is friction is directly proportional to the displacement, that is f is directly proportional to dx by dt with respect to time. Okay. Also we can say that change in displacement, where this b here corresponds to a frictional constant. Okay. So this is basically about damping. Okay. So we have a friction representation here. To represent friction, we use these kind of notes here. See. Okay. And this is the basic friction where two voltages are applied. If you want, you can note it down. This is not so important, but during the problems and all, I'm going to explain it to you further, that how to do this. So the another one concept, very important concept, that is related to the spring action. Okay. Spring. This is also a very important concept. Spring. So what is this basically a spring? You people have been seen spring, right, in your life. So yeah. For spring is basically where a force is required to cause displacement in the spring. That is no linear but approximated linear behavior. That is, whenever you pull a spring, right, we need a minimum amount of force as well as minimum amount of friction in order to conduct this spring action. Okay, so that's why. So here spring is represented as force is directly proportional to displacement, where force is equal to k into x of t, where k is known as spring constant. Okay. So this way the spring is represented here. You can see that. Okay. And here the spring in case where two voltages are applied. Okay. Yeah. So that's all. So now one more concept is I have forgot to discuss, that is mass. See here, mass, you can see, right? What is basically mass? Mass, we know that mass of an object, we can say that it is basically weight of a object, not human being but an object. Okay, mass. But in this control system, the mass is directly we can say that mass without force and acceleration we cannot find mass. Okay, so in order to find mass we need to know the force and acceleration, and when we have a relationship between this mass, force and acceleration, that is, we can say that force is equal to mass into acceleration, right? So this is a formula that you need to know. From this we can say that mass, force is equal to m into dv by dt, that is rate of change of velocity, that is corresponding to acceleration. Okay. Or also dv by dt is equal to d square x by dt square, where voltage, we know that rate of change of voltage is equal to rate of change of displacement, right? So we get like this kind of formula, that is m into d square x by dt square, where this m corresponds to the mass constant. Okay. So till now the three concepts which we have discussed along with the transfer function, that is mass, damping and spring. Okay. So please make a note of these. Okay. Whenever I'm saying you all, please pause the video and make a note of these, because these are very important concepts. Okay. I know it's a bit blur, but I've read you out. So yeah, please make a note. Yeah. So in the next video, so that's all for this video. So in the next video, we would be discussing few of the more concepts, and in the upcoming video, after that concept video, we are going to discuss problems. Okay. So the problems here in this control systems are very interesting. Okay. It is very very interesting to solve. Once you know the method, you can solve all the problems in a very easy manner. Okay, so yeah, please like, share, subscribe. Please stay regular to this channel, because we are planning to upload one video at least in one day. Okay, so in upcoming days you are going to get the regular videos, so please stay connected to this channel, share this channel to a huge number, and please like, share, and support this channel. So yeah, that's all. Thank you. See you in the next video.